All right. Well, let's go. I'm going to share my screen. You can see the agenda. If y'all have stuff you want to add, feel free to add it to the agenda here. Paste that in the chat room in case anybody missed it. Copy link URL. There we go. No, that's the Zoom link. That's not what I want. There we go. And I'm not sharing nearly enough of my screen, am I? Let's try this again. Share the whole desktop, all the things. Awesome. All right, well, let's jump in. I'm going to go through the stuff that's on the agenda. If you've got something else, add it there or just shout it out. Looks like Sal has the first question here. Something about how does the callback function recognize the error function / object if error is a variable defined within the function scope? Sal, do you mind? I thought I saw Sal on the call. Sal, are you here? Do you mind expanding on that a little bit?
Yeah, sure. So my understanding that error with a capital E is it's a function built in a node, and basically returns the stack, it traces the stack of the process and where did the error occurred, and also puts a limit to it, like how many lines of that stack you want to show. My question is that if the error with the ERR here at the read file function is a variable that is defined within the function scope, when an error, how does it recognize that an error has occurred, and then to throw that error to show that error? Like, how is that compatible with the function error with the capital E?
Gotcha. That's a great question. So yeah, let's look at what's going on here a little bit, and I'm gonna let's use this code. We'll just use this here as an example. So paste a string with tabs. Oh no. So here's the code we have here. We're doing a read file from a path. So so to simulate an error here, I'll just try and read from a file that doesn't exist, right? So that should give us an error. So the difference between the two things you're talking about, one is this error, which is a function in JavaScript. It's actually a constructor function. So it allows us to create new errors with a message. So when I do this, I'm just creating a new object, just like I might create objects in any other way, right? So I can say my error is this new object, and let's actually start with that. That's a better place to start. So let's say I have some function that does a thing, and in that function I can create an error. And let's say I've got some other function that just calls do it. So I have some sort of nested functions here, right? Start it calls do it, and then start it maybe gets called at the top level here. And down in do it, I'm I'm creating this error, and then I'm saying throw my error. So if we run this code, we'll get a big old error message here that shows us like we would expect, right? We had an error in the doIt function, which is being called from the startup function, which is being called from this global scope. We get this kind of big stack trace here. But we can see sort of the path down to right where the error was thrown. And we also see the message that we typed in, something went wrong. But as you can see here, this new error is just creating that error object, and then we have to subsequently throw that error. So if instead of throwing that error, we just logged we just logged it. My error, I think I can look at the stack of that error, for instance. So let's log a couple things here. Let's log the stack, and let's log the message attribute of that error. So this my error object that we've created has a couple of attributes. And message and stack are two of them. And so I'm not throwing the error here, I'm just logging it when do it gets called. And we can see that in that case, right, there's the stack, there's that big error message that we recognize, right? That includes that path to do it and start it. It's kind of printed a little weird here because it's part of an object. And then there's that message, something went wrong. So the error objects are something you can create in JavaScript that will automatically include sort of the path to exactly where they were created, and then the stack of how to get there in the code, and then some sort of error message. And then one thing you can do with error messages is to throw them like we saw initially, right? I can just say throw, if I spell it right, I can say throw my error, right? So that's what we saw initially, which just kills the program with this big error message. Now, so see shell returned 1 is my shell's telling me that like this program just crashed. But another thing I could do with error messages is pass them around and call other functions to them. And that's what's happening in this read file situation. Since read file is an asynchronous method, it can't throw an error when something goes wrong reading the file, because it's too late by then, like nobody's listening. The way it is going to give you information about the result of reading the file is it's going to call the callback function that you passed in. And so by convention, it's going to do something like this if there's an error. So let's say our doIt method took a callback, just like the read file method does, right? So what read file is going to do is something like this. It's going to call the callback, and if there's an error, it will call the callback and pass in the error object as the first parameter. And if there's not an error, it's going to call the callback with null as the first argument, and then the result of reading the file, you know, file contents here as the second argument. And so there may be, you know, there's going to be some code in there sort of checking for errors, and then either doing this line 8 or this line 10. You can think of it, it's probably a little more complicated than this, but you can think of something went wrong. Think of like a sort of an if block happening here where it checks to see if something went wrong, and if something did go wrong, it'll call the callback with an appropriate error. Otherwise, it'll call the callback with the results of the file. So we can simulate something went wrong here by just setting that to true. And then in doIt, we can pass in a callback that's going to look a lot like this callback to read file, right? We'll expect two parameters, an error and the data. And then in our function, we can check and see, is that error argument null? Did we get passed in null as an error, or do we actually get passed an error in? And that's what that if error is doing. And in this case, in your example, you're just checking to see, was there an error argument passed in? If there was, then just throw that error, and that will sort of like cause your program to terminate and print out that message. So that's what's happening there. Boom, boom, boom. Throw error. Otherwise, you've got this log data, right? So that's what's happening. And so now since we have something went wrong set to true, we're going to hit this if condition, which will cause us to call the callback with one argument, my error, right? Which will get set to error when this callback gets called, and we'll hit this if block here, and it'll say, oh, error is not null, so there was an error. Let's just throw that error.
Sorry, how does my error get set to error? Well, when you just mentioned that when it checks the if function, and then you said my error is gonna set to be error.
Right. So do it is a function that takes a callback. So maybe it's probably a little clearer if I do this way. Let's take this callback function I'm defining and define it down here. It's just a regular function. So this is the equivalent thing, just in more explicit syntax, right? So I have this function, and I'm passing, and this function is going to be my handle do it results. So what I'm doing here is I'm taking a function and I'm passing that function as an argument to another function, right? That's how callbacks work. And this is the same as what we had just prior to this, where we were sort of defining the function right here. This is exactly equivalent. It's just a little bit more verbose way to do it, where we're going to like name the function down here and then just pass the name. We're going to reference it by a variable. It's the same thing as what's happening up here on line 1, where you're sort of defining this function in line. Here, we're just defining the function down here and naming it so that we can, store it in a variable, essentially. Does that make sense? Like how the callback's getting passed in to do it?
Yes, it does.
So then in do it, we this handle do it results gets stuck in callback, right? That's what we're naming our first argument to do it in its definition. And so down here, we take that callback and we call it. So callback's a function. We call that function and we pass in one argument and we give it my error, right? So just like any other function, when you call it with some arguments, inside that function, those arguments have the names that are specified in the function definition, right? So my error is being passed in as the first argument. So in our function, we'll reference that using error. We could call this anything we want, right? We could call this Steve and it would work the same way. Error is just what we've chosen to call the first argument to our function, which semantically we expect to be either null or an error object if there was some sort of error in do it. Does that make sense?
The last part, not so much, but I'm trying to understand the last part of it, of how.
Yeah, sure. So is it still, you're still having a little trouble following how my error gets an error end up being the same thing?
Yeah, that's exactly
okay.
the last part.
Yeah. So let's look at maybe a more familiar example. Say you have a function called add, and it takes two arguments, A and B, and returns A plus B. It's my favorite example function. And then say you have some constant called number. Let's see. Age, my age. I just had a birthday, so let's do this. So my age before my birthday was 33. And so then I might call, to get my new age, I might say new age equals add my age and 1. So here, right, I'm calling add with my age and 1. So in this function, A is going to have whatever value my age had in it, right, which is 33. And B is going to be set to 1, right? Just like basic function parameters. So the same thing is happening when we specify a callback. A callback is just an argument like any other argument to a function. So here our handle do it results, just like our add function, has two parameters, which we're calling error and data in the function definition. And really whatever gets passed in as the first and second arguments to callback are going to get stuck in these two variables, error and data, when the function runs. So the first argument here is this error that we just created, which up here we called my error. And since it's the first argument to the function, then when the function runs, it'll be called error, right? That's the name of the variable for the first function, for the first argument to this function in the definition. Just like A is what we're calling the first argument in the add function, regardless of what it's called when we're passing it in here. Does that make sense?
Yes. Yeah. This part makes sense.
Cool.
Yeah.
So your original question about how, let's go back up to the actual example code here, right? So your original function, your original question here, I guess I'm going to need to actually require fs for this to compile. So your original question about like calling read file, and then you've got this callback here, and the relationship between this ERR object and the error function in JavaScript. What's happening is, as read file is running and it's trying to read the file, if it encounters some error when talking to the file system, for instance, the file doesn't exist, it's going to create a new error object internally, right? Probably by doing something like new error and some string about like, you know, that file, I can't find that, right? And then it's going to take that error object and it's going to call your callback, which you've just defined here, which is just a regular JavaScript function. And it's going to pass as the first argument to your function the error object that it created explaining what went wrong. And so you're going to check for that error, and if it exists, you're going to throw it so that you'll never get to this log statement. Your program will just sort of end and print out that error, right? So if we run this code, we'll see, there it is. No such file or directory when trying to open ain't no file, right? So here's the error that read file created when it was unable to read the file based on an error it got from the operating system. And it passed that to your callback function, and your callback function chose to throw it. Your callback function could also choose to take other action, right? It could say, got an error, printing my name instead. So it could just choose to take some other action, right? Well, if we couldn't find anything in the file, let's just print out something, right? And we could move this into an else. So you don't necessarily have to throw the error. When you get it back, you can look at it and choose what you want to do. Maybe your program is smart enough to know what to do if that file doesn't exist. So in this case, the program doesn't crash. We don't get this big ugly message. We just get some logging because we noticed that there was an error. Does that make sense? Does that answer your original question, or is there there's still something?
Yeah, no, this is perfect. Now I understand.
Great.
Thank you.
Yeah, no problem. All right. Well, let's move on. The next thing in the list here is finding HTTP rec and res object methods. For example, res.setEncoding, res.on, and https.request, which are not in the Node.js web documentation. That's Debrina. Let me just, Debrina, you're here, right? Yay.
Yeah, I'm here.
Okay. Is there anything else you want to add about that? It seems pretty straightforward, so I can just jump in unless there's more context you want to give.
No, in general, like I went through the HTTPS and HTTP documentation, and I wasn't able to find like some of the methods that I was seeing being used in a lot of examples, and kind of got frustrated. Like I don't know if I can recreate some of the tutorials that I've gone through by myself without those tutorials, because I don't know where to find a list of methods like you would find on MDN for arrays or objects and so on. Right.
That's very understandable. It actually took me a minute once I started digging into this, like, wait, where are those things defined? And you kind of have to follow a couple of threads. So let me walk you through what I did to find this stuff once I saw your question. And hopefully it'll make more sense. So the request and response objects are, that's something provided by Express, right? Which is the web application framework you're using. So if you go to the Express documentation, there's the API reference. Let's start with the request, right? So here with the request, we have all of these properties that are defined on the request, methods and properties for the request. And the ones you're looking for, like set encoding and on and all that stuff, they're not in this list, which is, I'm sure, what was causing frustration. But there's this little line down here at the bottom of the introduction to the request saying that the request object is an enhanced version of Node's own request object, which supports all built-in fields and methods. So basically what they're saying is that Express has sort of built some extra functionality on top of the built-in HTTP request object that Node just ships with, right? And there's this link here to the Node documentation where those request objects are defined. So if we click on that, it takes us to this Node documentation for class http.incomingMessage. So what Express is saying is that our request object is this HTTP incoming message object with a bunch of stuff added into it, right? We've added some special stuff to make it easier. So we get to this documentation, and you will still not find set encoding and on listed explicitly in here, right? We see we got message headers and we got other stuff going on, HTTP version, but not the stuff that you're looking for. And again, if you look at sort of the preamble to this documentation, one of the things it tells you is that this object, HTTP incoming message, implements the readable stream interface, as well as the following additional events, methods, and properties. So the Node incoming message implements an interface called Readable Stream. I'm going to slow down for a second and just explain what an interface is. An interface is a concept in programming, generally in object-oriented programming. You'll hear that term. And the point of an interface is you have some common set of behaviors or methods that you want all objects of a certain type to respond to. So let's think of a good example. So let's just use this example. So in Node, there's this concept of a readable stream interface. And the idea is that there are a lot of situations, there are a lot of objects sort of built into Node that handle reading data from somewhere, right? So in the FS module, you'll have methods that allow you to open up a readable stream from a file or from standard input, where you're reading data that's coming in through some pipe, maybe from a file, maybe from another program, maybe from a TCP connection over the internet. But in each case, there's a lot of similarities, right? You're reading data, it's coming in over time because of the time it takes to read from your disk or to get the bytes over the internet. And those are all very similar tasks. And it turns out to be really powerful if every object that represents this sort of reading data from somewhere, if each of those objects all have the exact same set of methods for reading the data and telling when the data was finished and you received it all, if all of those objects implement the exact same set of methods that act in the exact same way, then I, as a programmer, can write one function that handles a readable stream, and it doesn't matter to that function whether it's reading from a file or from a TCP connection or an HTTP request or any of that stuff. And so an interface is sort of like a standard. It's kind of like a protocol that says, okay, anybody who wants to implement an object that sort of abstracts the details of reading something from a stream, please implement these exact methods this way as the way that other people can talk to your object about reading that data. And it allows other code to be greatly simplified, right? Because now you can just write code that can handle anything that implements those methods. and you sort of have a common protocol. It's just like the HTTP protocol, for instance, right? Like all the servers on the internet just sort of agree that like, hey, we're all going to use this language. We're going to right. So anyway, so the HTTP incoming message class implements the readable stream interface. So if we click through to that, we'll see that the readable stream interface defines all of these common functions for reading a stream.
Right, these look familiar.
Right, in here you're going to see all of these events. We'll see that stream readable, we may have to scroll up just a little bit here to the top of this file, but all these readable streams, it gives you an example of a bunch of different things that implement this interface. And somewhere in here it's going to say that these readable streams all implement the event emitter interface. And the event emitter interface, I'm not going to click through to that, but that's basically what that .on method is. So event emitter interface is for any objects that sort of have asynchronous events happening over time, and you want to allow people that are interacting with your object to register callbacks for those events. So like, hey, when the files, when I'm done reading this stream, please do this. When there's an error, please do that. And that's what that .on function is. That .on method is part of the event emitter interface. And then this specific event emitter, the stream readable, defines these events that like, okay, you can register callbacks for when the stream closes, for when new data comes in.
I was wondering where chunk came from, and now I see.
Yeah, there it is. There it is.
Yeah.
So, right. So that stuff's a lot of the methods that you were asking about are part of this readable stream interface. And if we scroll down here far enough, I'm pretty sure we will find set encoding. Let me just see, set encoding. Yeah, there it is. Readable set encoding. So there's that one. So you kind of have to dig through because these objects are sort of built on other objects or extensions of other objects or implementing certain spaces. So it does take a little bit of digging. But that's where the documentation lives.
Yeah, I wouldn't have honestly known where to start. I wouldn't have thought that readable stream had anything to do with the .on method. Also, I just want to like clarify, because you started with Express, and I was kind of like bypassing documents that had anything to do with Express because I was under the impression like that Express uses Node to allow us to work with the request and response objects, and that it's an extension of Node with extra stuff, and not the other way around. Am I right in assuming that?
Yeah, Express is sort of built on top of Node, right? Just like your programs are built on top of Node.
Yeah.
So you're creating new functions that aren't a part of Node, but will end up calling functions that are built into Node, like fsread file, for instance.
Yeah. And
Express is like that. So it is using some like built-in Node methods and objects for like doing the HTTP connections, but it is adding stuff on top of that. So it's sort of a layer on top of Node. If that makes sense.
Yeah.
Yeah.
Thank you.
Yeah, no problem. Does that kind of answer all the questions you had? Did I cover?
For now, yes.
Okay. And I tried to write all that up in the agenda, because I know that was a lot of clicking and things to follow. I just put some links in here, so hopefully that'll give you.
Yeah, that helps a lot.
Okay.
Thanks.
Awesome. So finally, we've got using mock data to test functions in the movie search CLI. This is Latoya's question. And Latoya, you're here. This is another one that seemed pretty straightforward. I'm happy to just jump in. But if you've got, if you want to elaborate on this at all or give some context.
No elaboration right now. I guess I'll just see what you're going to do, and then I'll ask questions as we go along.
Please interrupt me if I start going off on a tangent.
All right, we'll
do that sometimes. So this is a great question. And movie search CLI is kind of the first time you get to this point where you're testing something, but like your code depends on Imdb, which is like this thing out on the internet, and like it's awkward to test, right?
Yeah, I was like, I know all about testing emotion chat until I got to this point. I was like, what?
Right, yeah.
Happening?
So this is actually a really common problem once you start building web applications of any complexity, is that your web applications start to depend on other web applications, either other services that your company has created that you're talking with, or systems that are like this, right? You're just hitting some API on the internet for Imdb or GitHub or Google's authentication or whatever. And you have to try and test your code, but it's awkward to have test code that actually, like, during the tests goes out and hits some external service like Imdb. Makes your test really slow because it takes forever to like make that request. And it makes your test really brittle because now if you don't have an internet connection, you can't even run your tests. And if Imdb goes down, your whole test suite starts to fail, which is just a hassle, right? There's nothing you can do about Imdb going down, so you don't want your tests to start failing just because Imdb is having some issues today. So there's a couple of solutions for this. And luckily, I have a repository where I've worked through the movie search CLI benchmark and kind of written up my own solution. And I've got a couple of different branches on there that explore two different ways of solving this problem. And I've linked to those in the agenda. So the first one I'm going to talk about is knock. So knock is a module that attempts to solve this problem by letting you basically fake out the Imdb responses. So knock lets you say, okay, you can define in your tests, and you can say something like, all right, if my application makes any requests to this given URL with these certain parameters, intercept that request. Don't actually send an HTTP request over the internet. Just immediately respond with this data. So what we can do here, let's see. So here's my tests for my movie search CLI, and I'm testing a method called query Imdb, which we can see here. We don't have to go through it line by line, but it's making this HTTP GET request to Imdb, right, to like find this query string. So in my test, I import knock, and then in my test I say I'm gonna knock out this Imdb URL, and any requests that start with /find that have a query, I'm just going to reply immediately with a 200 HTTP response code and this block of HTML. And this block of HTML is sort of like the minimalist representation of what the HTML on the response page at Imdb looks like. So what I did was literally I went to this Imdb search page, Imdb find, and I just sort of like, I did an inspect, and I saw that, okay, so let's see what we're looking at here, right? There's a find section that has a find list table in it that has some table rows with result text, right? And that's kind of what we're seeing here. Like, here's that result text. Here's the find list and the find section. And you can see that like I'm leaving out the vast majority of this page. I'm just pulling out an HTML that looks just enough like the Imdb search page that my method will know how to handle it. And we can see in my query Imdb function, somewhere down here, I've got this parse results page, and you can see that it's looking for a find section. It looks for the first find section and then finds all the result text rows and processes them, grabs the text out of them. So this HTML looks just enough like the Imdb search page to like get my function to work. So I'm just sending back this like mocked up response. So then in my test, after I set up this sort of this knock, then I just call my function. I call query Imdb with finding Nemo. And in my function, once my function does the HTTP GET, knock has sort of inserted itself in that flow, and it'll intercept that request before anything gets out onto the internet and immediately respond with this raw string as the body of the response. And so I can just expect that, like, all right, when I call this function, my function's gonna like get this HTML and it should know how to process it correctly, and it should give me these results, Rocky and Rocky 2, which are the the movie names from my mocked out response. And again, then since all this is happening asynchronously, right, I have to call done here inside the callback from my method to let Mocha know that I'm all done with this test. Does that make sense conceptually?
Yes, it does. And can you scroll down just a bit?
I can, yeah.
Okay. Because
So this is just
another test here?
Yeah,
Line
this is just
30.
another test.
Okay.
Yeah,
Okay.
so the first test tests the case where, like, everything happens correctly and the page returns actual results. And then this second test is a simulation of what IMDb looks like if you search for something and there are no results for that thing. And so I'm sort of testing in that case that I get just like an empty array and not any sort of errors. And the catch, the thing you'll get hung up on with knock, is that knock registers these, it sort of shuts down your ability to send out requests over the internet. And it's registered these interceptors, right, for certain URLs. And that stuff stays around unless you explicitly tell it, okay, now please stop intercepting HTTP requests and reset everything to normal. And so what I've added down here inside my describe block that includes both of these tests is an after each callback, which says, okay, after every single test runs, call knock clean all, which basically tells knock, get rid of all the interceptors and all the things that were set up and reset everything back to normal. So that at the beginning of each test, we start with sort of a clean slate, and we can set up whichever knock we need just for that test, and we know that it'll get cleaned up as soon as the test completes. Does that make sense?
Yeah, and then just with the done, that has nothing to do with that block of code for line 43 to 46. Done is just saying we're done with this test.
Yeah, done is just the standard, like, way Mocha handles testing things that are asynchronous, right?
Oh, for asynchronous.
Right, yeah.
So like
this,
with our...
Go ahead.
Oops. So with our like interview to get into phase 2, I didn't use done. Is that because all that stuff was synchronous?
That's right.
Okay.
Yeah, exactly. Yeah. The done is something that comes into play once you're testing asynchronous things like a network connection, right? Because query IMDb is an asynchronous method. I'm going to call it. It's going to initiate this HTTP request, and then whenever that request is done, it's going to call my callback with the results. So I actually don't know right away whether or not query IMDb works. I only know once the results come in and my callback gets called. So I have to wait for the callback to get called and put my expectations inside the callback, right? Because that's when I actually get an error or some results. And then inside my callback, I have to call done to tell Mocha, okay, the test actually finished. You can move on to the next one. Does that kind of make sense?
Yeah, it does. And then lastly, with expect, I see that you're using expect. What I learned from the beginning was assert. And so that's just what I naturally gravitate towards.
Sure.
Is there any reason why you use expect over should or assert?
It's just personal preference.
Yeah.
It really is. Yep. I like the syntax better. That's basically all there is to it. I think assert is perfectly valid way to go. Should is a little messy. I don't have a strong opinion about it, but with should, you're doing things like result.should. And so what's happening there is that, like, the child library is actually adding methods to like every object so that you can take any object and then say should on it. And it's a little bit of a code smell. It's a little messy to have your test library like actually altering your objects to add methods onto them. And there's like a few cases where that could get you into trouble. It's not a huge thing to worry about, but it's another reason that I tend to gravitate towards expect, which just has a little cleaner separation between the test code and the rest of the code. But I would say, you know, like find the one that you like the way that it reads, that you feel like makes your tests the most readable, and just go with that. They're all perfectly fine ways to go.
Great, thank you.
So this was method 1 for handling the testing something that depends on a third-party HTTP call. The downside of this is that I have to write all of this raw HTML right into my test. And there's 2 problems with that. One is it's messy. Well, maybe let's say there's 3 problems. There's probably lots of problems. One is that it's messy. The second problem is that this HTML, as you've probably noticed, differs in a lot of ways from this HTML. Let's actually view source on this page, right? There's a whole bunch of stuff going on this page. Lots and lots. I haven't even gotten to the HTML yet. This is all still like scripts, and then there's all this mess going on. And so I can sort of, I've built this sort of toy implementation of it that I feel like is good enough to test my method, but it's not a real accurate representation of the HTML that my method really needs to be able to handle. But I certainly don't want to cut and paste this entire page into my test, because that just exacerbates the problem of how messy it is to have HTML hard-coded into the test in the first place. So those 2 things are suboptimal. And the other thing is, every time Imdb does a redesign and changes their page, I'm going to have to come in here and manually update this HTML to match. And there's no getting around having to update my test when Imdb redesigns their site, right? Like I now have a dependency in my code on the way Imdb looks. If Imdb changes their page, that's basically the specs of my code changing. Now my code has to handle something new. I will have to come and update my test. But it is, this whole process of like writing this HTML out by hand is a bit messy to begin with, and have to keep doing that every time Imdb changes their page is difficult, and requires me to keep going to look at Imdb manually and look at the source and make sure that they haven't changed any of their class names or anything like that. So there's some downsides to this method of doing this. And that is where the second option comes in, which is in my master branch on the same repository, which I've linked to from the agenda. So let's look at the tests for this. So this is the same test. Now, instead of using knock, we're using something called replayer. And what replayer does is similar to knock, but it adds some convenience methods on top of that for you. So replayer, let's look at their page here. It's an NPM module that I've installed. It was originally built by LinkedIn, I think, and then it ended up getting forked and renamed. But what it allows you to do is you install it, and it just listens for any network requests at all. And it looks for an environment variable to be set. So you can run your tests with different values for this VCR mode environment variable, and that will trigger replayer to act in a couple of different ways. So let's actually look at some code here. So if you look at my package.json, you'll see that my test script starts with this VCR mode playback. That's the default. And I have this other mode called VCR mode record. So what happens is I set up my tests, and you'll notice in here I'm not doing any knocking. I'm immediately calling query Imdb in both of these tests, and just expecting certain results to come back. And what happens is the first time I run these tests in with VCR mode set to record, let's do that. So npm test record is the script that I created, which just runs the normal like mocha test command, but it sets that environment variable first. So as I run this, oops, sorry, I have to say npm run test : record. My tests run, and you'll notice they're slow. Did you notice that pause there when they ran? And then I can see that this can find Nemo test took over 2 seconds to run. That's because in the test, I actually made a request to the IMDb server and downloaded the results and like tested it on like the actual live HTML from the site. But what happened, because I have replayer installed, is that in addition to like making that network request, something else happened, which we can see, I think if I do a git status here, we see we have this fixtures directory that has all of these new files in it now. There's 2 sets of them, right, that have the same name, and each one has like a file with this like big old hashy name and then a same file with a .headers extension. And if we look at just the first few lines of one of those files, we'll see that like, oh, it's the beginning of this HTML page. This is actually a copy of that IMDb page. So what replayer did is when the request got made in record mode, it actually recorded the results from that request and saved it in this fixtures directory. And what that allows replayer to do is when the tests are run in playback mode, which if we go back and look at my package.json, we'll see I've added VCR mode playback before my just regular test command. So now when I run my tests normally, I'm saying VCR mode to playback, which tells replayer, hey, operate in playback mode. And in playback mode, replayer will not allow any requests out to the internet. And it will instead respond to any requests to the internet with the saved versions of those files that it has in the fixtures directory. And so if I run the test this way, we'll see they're a heck of a lot faster, right? This one's 100 milliseconds instead of almost 2100 milliseconds because it just went to the file system and grabbed that file instead of actually contacting IMDb. So this sort of automates the process of using something like knock to intercept the request and then manually writing HTML directly in your test. This sort of automates all of that so you can run your tests one way to sort of create all of these exactly accurate HTML fixture files that have the exact HTML from the site. And then in your normal test suite, you just use those files. And so now your code is being tested on exactly what the IMDb page looks like. And it's really easy to come back later. You could periodically, as part of a build process or whatever, run the tests in record mode once a week or something to make sure that you're operating on the most recent version of what IMDb looks like this week. And you can sort of check those files in with your code, and that way your tests run fast on like really accurate representations of the site.
Awesome. And now when you said save files, are you referring to the files that were just created?
Yes.
With those hashes? Okay.
Yeah. Yeah, and the hashes are, just sort of like uniquely identify the type of request that was made. Let's see, Git status. Yeah, so fixtures. Let me see if I can right. So if I open this file, right, this is just pointing to the file on my file system, and you can see that like it is exactly like the IMDb page. Even though we're not hitting IMDb, we're just looking at my files.
Oh yeah, okay. Because I was about to say, like, if that page gets updated, then that file will be modified. But I get what you're saying. The file is just that, a file, a copy of that.
It's a copy. Yeah, you're just saving a local copy of the IMDb page, and that way your tests will always run, and they'll always be running against the same data, right?
Yeah.
And then, periodically you would want to update these files to make sure that if if IMDb changes its pages, you want to make sure you have like an up-to-date copy. But you don't want to do that every single time your tests run, right? Because you're going to be running your tests way more often than IMDb is going to be doing site redesigns.
Right.
So yeah, that's very handy. And you can use the same method. Like here, we're scraping an HTML page, right? But you could use the same method if you were hitting some sort of a REST API that was just returning JSON. This exact module would work as well. These files don't have to have HTML in them. They can have whatever kind of response you're getting from your HTTP requests.
Right, and the JSON would be in reference to the weather app that we had to build in that exercise.
Exactly, yeah.
Okay.
Exactly. And like I said, I linked to those 2 modules and to those 2 different branches on GitHub of like my solution, so you can see an example of the implementation. Yeah. Does that answer all the questions you had about that, or is there more?
Yeah, in great detail. Thank you so much.
Great. Does anyone have anything else? We're to the end of the written agenda. We've got some time. If there are any other questions. Awesome. Well, thanks for showing up with awesome questions today. I know I've been a little less available this week. Hopefully you guys are doing all right and able to move forward in your learning, as we are taking a week to slow down a little bit and consider the way forward. But reach out if you need anything. I will do my best to be responsive in between meetings and the like. And I will see y'all soon.
All right, thank you.